brief you about the today's speaker, Ravindra Joshi. He is a founder of Motorall company. So Motorall company is based towards they are usually working in the field of research and product development, especially in EV powertrain, motor designing technology, then battery technology. So today's topic is related to the battery technology side, lithium-ion technology. What are the innovations are there? So welcome, Mr. Ravindra. Hi, Ravindra.
Yeah.
Yeah. So
Hi.
welcome, Ravindra, in our session. So our audience is excited to hear the subject that you have selected to brief you about the idea in the innovation of battery technology and what are the things is the waste management side. So yeah, hand it to you.
Okay. So firstly, thank you to the Gyaniki platform for having me. We have been talking with each other for quite a while regarding the same topic. We understand the importance of this topic, taking a look at the current demographics. When we had an initial interaction, we would like to educate our attendees as well that what is the main focus or what is the main goal of creating such session. Basically a 1 hour tech show or tech talk on how do we recycle the battery pack and what is the challenges, opportunity being lined around it. We To give you a small agenda about this conversation is to have an initial touch base or initial introduction about this current technology. How do we incorporate that by putting up a plant or putting up a factory? And what are the things we have to take a look at while going ahead with a battery recycling unit? What is the means of finances and as well as what is the amount of capital which goes inside it? So the major aim is to have an initial touch base on each and every part. How is the tech working out, and what are the different ways of doing it, and why is it so much important in the current conversation? So without further ado, I guess we have already been spent a little bit of time due to technicality. We'll start off the session and we'll share my screen and then we can go ahead. In between, if you have any doubt, let's have a chat. Let's have an interactive session to discuss about your problems as well as our insights as well. So I'll share my screen now. In this current presentation, in the current conversation, we'll be taking a help of one of the company, Customized Energy Solutions. They have a report which is being published as well. We'll take that report. We'll try to discuss that report only because I think and what I believe is that this report has some exhaustive amount of information which needs to be discussed and which needs to be have talked about. So we will go ahead with this. Initially, the battery recycling has come into picture because the amount of development been happening in consumer electronics and the other domain of electrical vehicles. We need high power density battery packs. There are two types of battery pack which is currently being in conversation. The highest one is the lithium-ion battery pack. A lithium is a component which stores a lot of energy, or whenever it loses its electron, we get about 3.2 to 3.7 voltage. And because of this reason, the voltage of the overall cell increases. And we have two types of cell, lithium phosphate and lithium ion, which have about 3.2 and 3.7 voltages respectively. That's the highest among that group. Other than that, we have sodium ion batteries as well, where the rated voltage of per cell would be in a range of 2.3 to 2.5. Then we have nickel cadmium cells and other cells as well. But amongst all of them, when we say about rechargeable cell with rechargeable with its cell utilization up to 95 to 98 percentage, lithium is the first choice of preference for any other premium storage application, be it in aircraft, automotive, or any other domain of rich renewable energy storage system as well. The demand for lithium, because of this, the demand for lithium cells or lithium material is increasing at a very drastic stage. Now we can have an argument that lithium is being procured either from its ore, that is some pedalites and other ores, which is a prominent source of lithium, or else it can be procured with the help of brine as well. Brine is a seawater. India is a peninsula-based country where we can we can have a salt mine, we can extract lithium from the seawater as well. But on the other hand, that has a very low amount of utilization or the amount of concentration of lithium which we require. A ton of seawater would roughly be having about roughly we will have about 0.5, 0.3 percentage of lithium only. That is the reason we are also dependent upon other sources of lithium, and that's the ore part, where about 5% or 3% of lithium would be there, along with its impurity, sodium and potassium and other chemicals. Now, the extraction of these ores as well as brine solution is very hard, and that's why it becomes very necessary to extract or to recycle the lithium which is already being extracted some other facility or some other countries. That is why there is a lot of buzz around extracting lithium from the existing waste which is being created. Similarly, we can have an argument about cobalt, and we can have an argument about nickel and graphene and phosphorus as well. And that's the reason why we have lithium ion recycling or lithium battery recycling growing at a very staggering rate of 22% CAGR. The market size for this lithium-ion battery packs is increasing at a very large volumes. There are companies whose CAGR value with respect to revenue is growing at a 50%, 40% to 50% rate. And there is a huge demand for lithium-ion recycling as well. India has total dependency on other countries for the sourcing of lithium. And going ahead, if we are going ahead with manufacturing of lithium-ion batteries in-house in India, we require such type of tech in-house, or such type of raw material in-house. Yeah. We have mentioned that due to the usage of electric vehicles, due to the exhaustive usage of consumer appliances, as well as renewable energy storage system, you have more utilization of your lithium-ion cell, and that is how more requirement of lithium-ion recycling is required. To give you a perspective, a high power density lithium-ion cell, basically lithium titanate or else lithium polymer cells, which have more ratio of nickel, lithium, and the cobalt, roughly around 8 is to 1 is to 1 or 8 is to 2 is to 1. They would be consumed at drones. They would be consumed for consumer appliances as well as for laptops and consumer other consumer techs as well. With when we go just below that, we have lithium-ion cells, 36650 or 18650, which is being utilized by electrical vehicles. There are other standards of cells also, but the main chemistry remains the same. 4% will be of lithium, 7% would be nickel, about 22% would be cobalt and the graphene respectively, and then other metals as well, or other metal salts as well. Then if you go just below that, apart from A grade cell, we have B grade cells as well. B grade cells who have discharging capability of 95, 90% only, or even below that. Those cells are being utilized in rechargeable energy storage system for renewable system. So a renewable energy would generate power at the time of sunlight from solar cell. Whenever there is wind, so it will generate power at the windy time only. It will generate and it will store its power, and that storage system has to be lithium based. If it is lead acid based, it would create a lot of requirement for space as well. So lithium is also applied over there. And then we have C grade cells also, which is currently being applied with certain toys as well. And after that, we recycle the complete lithium ion cell. So we have different grades of cell. Different grades of cell will have different costing for for the resale value. The needs of recycling is the scarcity of critical new minerals. It takes around 15 tons of CO2 equivalent to extract 1 ton of lithium carbonate. So that's the amount of pollution and that's the amount of unsustainability we are taking a look at. And that it becomes very essential to extract lithium carbonate or lithium from the existing cell. Similarly, for cobalt as well, cobalt's market is quite dicey. The prices for cobalt as a mineral is not consistent. And that's the reason it is very essential to extract the cobalt and then sell in the market as well. That would become an economical solution only. Then there is an increasing business opportunity, increasing utilization of critical materials, and we have job creation, which is also being utilized for this current technology only. Then we have management of end of the life batteries. So this is we'll go step by step right from the start till the end. Let's say if we have a plant, what do we do with the first step for recycling of the current battery pack? The first step for lithium-ion battery pack recycling, we firstly dismantle the complete lithium-ion battery pack and we check whether the cell is healthy or not. Sometimes, many a times it will happen that in a battery pack, about 90% or 90 or 85% of the cells are quite okay. But there are few cells who have got due to difference in internal resistance, they have got overburned or they have got completely damaged, and their internal fluids have been extracted. This can be a reason, even if your one cell or 2 to 3 cells are being wasted, then this can be an issue. Now, due to this issue, we cannot waste the 90% of the battery pack. So what we do, we completely open the battery pack. We check which cells are working fine and which cells are working not. And then in that check, we check whether the cells is giving the efficiency or not, comparable to B grade cell or comparable to A plus or A grade cell. And taking a look at that, we segregate the cell that these cells are quite okay, and we can manufacture another battery pack from these cells, which can be applied for renewable energy storage system or telecom towers or wind energy as well. So this is the first step of sorting which we do. To give you an economical know-how about this process, uh, per kg capacity of per kg of a lithium-ion cell on a scrap would be selling at around 100 rupees or up to 1.1 or $1.2. However, a B grade cell would roughly sell at around $0.8, so roughly around 65 or 70 rupees only. So if you're buying 1 kg of cell, it would be selling around $1.2. Here, if you're buying B grade single cell, it would be a single cell would be around $0.8. So that's how, because the economics doesn't match hands on hand, it makes sense to extract the complete battery pack and check whether which cells are working fine and which cells are working not, and then extract the remaining cell, put it inside their own supply chain. So B grade cell would go into different battery packs development, and the cells which have gone completely bad, they will go into recycling. So that's the first step which we have to carry out. Then we have lithium ion cells technology. Now we have decided that these cells has to be recycled, and the other cells which are working fine, they can be used for renewable energy storage system as well. Now we have three different technology for recycling of the battery packs as well. Firstly is the mechanical separation, and then we have pyrometallurgy and hydrometallurgy. A mechanical separation for lithium-ion battery pack constitutes of a single shredder. In the single shredder, what a lithium-ion battery pack consists of plastic material. It consists of aluminum as well as nickel. It consists of copper and the black mass. The 45% to 50% of the lithium-ion cell constitutes of plastics, metal parts, and copper and nickel. And then the remaining 55 or 50% of the lithium-ion cell consists of a black mass. So whenever you're shredding the complete battery pack, a particular type of a shredder, which involves crushing, blowing, and many other operations, will separate the copper, nickel, and aluminum and the plastic separately, and it will give you black mass separately. Now, this segregation is essential because this plastics, once it's segregated, it will go at its own supply chain at 4 rupees, 3 rupees per kg. Aluminum will go at its own supply chain at around 150, 160 rupees per kg. And same with nickel. And then we have black mass. Now, black mass can be readily sold inside the market with the standard prices, but it is very essential to understand how do we treat the black mass to its further process to get the metal salts. Because with the current battery technology, battery recycling norms, it has become banned or it has become restricted to sell the black mass in the open market or to export the black mass. What Indian government is looking at is to recycle the black mass internally and get a source of lithium inside in India. So that is why we have second processes called pyrometallurgy and hydrometallurgy. In pyrometallurgy, we have a conventional process where we use calcination. In calcination, what we do is we get the black mass and we heat it at 700 to 800 degrees Celsius and then remove the plastic impurities. And then with further processes, we get nickel, iron, lithium as its own residue. We have silicon and iron and aluminum and nickel as its own residues, forming with different parameters. And then we have hydrometallurgy as well. In a hydrometallurgy, we use leaching and different other processes in order to extract the lithium ion cell. Now, I will just have a double tap on the pyrometallurgy part. Maybe a pictorial representation of pyrometallurgy would help you understand more. So we have one picture. I'll just share that. Yeah. So is my screen visible? Mr. Arpan, can you please confirm me? Hello?
Yes, yes,
Okay.
you
Okay. Yeah.
can.
So initially we have got the picture that we have active materials. Active materials basically constitutes of black mass. Now this black mass is being heated with the calcination process that will go beyond 700 degrees Celsius and it will have some decomposition and formation as well. Now this preheated process will have go under water leaching, and after water leaching we have further processes to extract lithium carbonate. Now, lithium carbonate is the core aim material. That's the process. That's the thing we have to extract. But other than lithium metal or lithium metal salt, we have other materials like aluminum, iron, as well as nickel, which is being extracted with the help of same process. Now, taking a look at the hydrometallurgy once again, we will understand that pyrometallurgy constitutes of lot of heat. There is a pre-treatment, there is a post-treatment, there is a leaching process from water as well. So it involves usage of heating, that's a furnace. It involves usage of water leaching, and it will involve a usage of high containers as well in order to extract the overall lithium. Now, because there is a heating, there is a process, so there is a chances that all the materials might get sticked with the crucible, and things cannot be hands-on very much high 100% efficient. So the efficiency for pyrometallurgy at its to its limited extent, and how do we improve that? That's another process for improving the pyrometallurgy's efficiency as well. Secondly, we'll go with hydrometallurgy. Hydrometallurgy is another process, and hydrometallurgy, the name itself conveys that in this process, we will involve a usage of lot of materials, lot of chemicals in order to extract the end material. With the hydrometallurgy, what we do is that we have one active mass or active material. We have black mass. Now, this black mass is treated with the help of a chemical process. We chemically wash the complete black mass, and then we get the lithium metal salt, lithium carbonate, in a form of different area. We have precipitation process, we have deposition process, and then we have solvent extraction and absorption process as well. So there are three different processes involved in hydrometallurgy. So we'll take a look at that as well. So we have active material. Now this active material has undergone to the leaching process. After leaching, there is a different acids which are involved in leaching. After leaching, we have precipitation process. In precipitation process, we have the pH adjustment and the overall thing being carried out after leaching. After leaching, we get lithium carbonate in a form of precipitate. In this particular process, we get efficiency of roughly at a good scale of 95% only on a lab scale. When you scale it up, the efficiency would go about 80% as well. Now, the thing with other processes is the solvent extraction and solvent absorption process. Extraction and absorption is a type of process. It's a process due to which the name is being aligned to it. On a commercial scale, solvent extraction and solvent absorption are not into picture. They are still into experimentation phase. And once these are ready to be commercialized, we can get the know-how that which process is better. But currently, the process which is better with respect to commercialization and which is readily commercialized is the precipitation process. In the precipitation process, we get the black mass. We leach the black mass with the help of the acid solution. Then we create a precipitate out of it as well. Now we have this precipitate, we have the powdered material. This powdered material is being passed on with the help of number of separators, and these separators collects the fine materials of lithium carbonate. And with the help of one separating machine, we shred the complete separators. We shred the complete separators with the help of a motor vibration motion, and then we get the lithium carbonate out of it. We get lithium precipitation from all of these three processes, and then we get lithium carbonate as a form of a extra material which is being received. We get cobalt and we get copper as well with the help of same process. Now that we have understand the three different processes for lithium-ion recycling, we'll take a look at what is the plus point and what is the negative point. We get an overall chart over here. We have pyrometallurgy and we have hydrometallurgy. We have single process called calcination. A big furnace is required for this process. And we have four different processes for leaching, purification, separation, and extraction. Now, because there is a difference in capex requirement as well, pyrometallurgy is definitely a easier option for lower financing, which requires lower amount of finances. We have sub processes called preheating, pyrolysis, and smelting. We have precipitation, solvent extraction, and selective absorption. The recovery rate for pyrometallurgy is high on a lab scale, but with respect to what we have received till now, about 80% of the recovery rate or 80% of the efficiency we can easily get with the help of pyrometallurgy. With hydrometallurgy, we get 99% efficiency of lithium, but on a scale stage, it can still go down to up to 80 or 85% only. So the cost for pyrometallurgy is high and cost for hydrometallurgy is low. And then we have other advantages that pyrometallurgy is being exercised conventionally in the overall industry. So you can have pyrometallurgy process being implemented. You will get easy labor as well. And then we have hydrometallurgy where a lot of management is required. It's a closed door process where a lot of chemical needs to be treated and they have to be treated automatically. So automation is also into picture. So we have different companies based on which we have different methodology as well. We have Kumiko, the Rosenfield, Acusar. These are companies who have incorporated pyrometallurgy and hydrometallurgy together. With respect to our experience and with respect to the data being shown, in Europe, there is a lot of fashion for pyrometallurgy and direct recycling. But for India, it makes sense to use hydrometallurgy process because of the higher efficiency and higher amount of purity rate as well. Then we have Indian customers who are based out in different area and they have different capacities as well. They're using hydrometallurgy as a core component for recycling of the lithium-ion battery packs. The current challenges for the lithium-ion battery packs. So we understand that the lithium-ion recycling is fairly new into the market, and because of the newness of this technology, it is not exhaustively available at each and every domain. We also understand that about 5% of the lithium-ion batteries are being collected and recycled in 2019. Now, in order to scale this operation, the Indian government has taken a battery recycling law. They have amended it in 2022, and they want to scale this operation to 70 to 80% by 2030. And that's the reason government of India is taken up with the technology as well, and they are providing technology with the Indian OEMs as well. For a better operation and for a better business model, it is advisable to go ahead with hydrometallurgy in India and go ahead with the battery recycling. If we are in a position that we cannot go upfront with the hydrometallurgy, then I would prefer going with a direct recycling, where you can at least get a black mass out of it, and then you can go ahead and sell this black mass to other companies as well. So the regulatory framework, so we have an aim of 70% of collection by 2019, 2029 and 30. And we want to recycle 80% of the battery packs, which is being collected and recycled in the overall process. So we have waste collection models. So there is a process of ERP system. That's the enterprise responsibility, sorry, EPR guidelines. So we have enterprise responsibility for collection all of the waste which is being generated. So let's say if a company is creating a model or creating a product which has to be implemented in the market, and they're utilizing some plastic parts as well. Over the time, they have utilized some 10 tons or about 10,000 tons and implemented in the market. The government has created some amount of mandate that you have dispatched about 10,000 tons in the market. Now it becomes your responsibility to recycle similar amount of tons with the other activities, maybe for CS, maybe with CSR, or maybe with other processes. But you have to recycle the 10,000 tons which is being poured inside the market because of you. Similar type of compliances a few months ago, Zomato has also completed, where Zomato's business model involves a lot of packaging, involves a lot of tapes. They have recently purchased carbon credits in order to neutralize the amount of waste being created, and that's how they can brand that all of our deliveries are carbon neutral. This has been done because of the purchase of carbon credits, but also this can be done with the help of CSR activity, and we can gauge how much amount of plastic being involved and how much amount of plastic is being recycled by them. So this is the EPR activities which even bigger enterprises are very much focused or keen in completing because of the government mandates. Yeah. Economics of study. So we will have the overall plan is to have a touch base for now. But going ahead, Arpan sir will also guide you about the bigger process or a bigger session for the lithium-ion recycling, where we will help you understand about the break-even cost, about the plant and machinery costs, and the overall process for the for the complete recycling plant as well. So we'll give you the financial models and we'll give you the supply chain distribution model as well. So we'll have a deep dive discussion on the same as well. Economics in India, we have different capacities, how much of the material we should buy, how much should we sell for, what is the market rate, how do we check market rate, and where do we sell for. Everything would be discussed in the in-depth and deep dive session. Yeah. Way forward, we see a lot of scope in other recycling batteries as well. We have nickel cadmium batteries. We have other types of batteries which has to be recycled as well. So those cells also have a lot of demand in the market, and because all the consumer appliances and conventional clocks, watches, everything would work on that. So going ahead, uh, creating a supply chain for stability of a stable supply of lithium-ion cell would make a lot of sense in the overall market to make the material available, as well as it has a lot of scope in export systems as well. Yeah. So with this, it is the end of the presentation, and I'm open for questions for the panel.
Yeah. Thanks, Ravindra, for the wonderful content that you have shared. So, from audience, we are now open to take the questions if Yeah, you can directly speak with Ravindra. Kalaivani, if you have any question, you can ask because you are working in the same domain, battery related things and charging related things.
Yes, yes, sir. Yes, sir. I have a question to ask, brother. Actually, my question is, for the 5 years we are supplying the EV vehicles. In terms of lithium-ion battery, how um, how horrible if they are dumping in one sector, brother, in the one area. But through the CSR department only, we are creating the awareness to the lithium. Why government to take the steps to creating the awareness to the government sector? Because government is a large number of procurement of the garbage vehicle. Say
Yes.
dumping one parts. So government, why should not government take the immediate decision to recycling the projects?
Yeah. So that's a very important question we have pointed out at. Government is actually working on certain aspects for facilitating this technology as well as facilitating the recycling of the lithium-ion battery packs. So there has been some technology transfer with government, which government has done for recycling of the battery packs, and basically it's all hydrometallurgical tech which is being implemented. Secondly, uh, a government would have a hands on it to a certain extent. While going to the bottom of the pyramid, an entrepreneur which would have a lot of connections in the market, which would have right sourcing of the battery packs, and then would exercise the overall business model to create profit, and that entrepreneur is required. So I see an opportunity for other entrepreneurs to implement this system and get the overall things in place, create profit as well as create a supply chain for the different materials. On one side, there are certain sites of government which would help you register that this is the amount of lithium-ion battery packs we have. So government itself will buy the lithium-ion battery packs from you, and then they will do their own recycling or they will do their own sourcing to recycle this battery pack and get the lithium out of it or other materials out of it. So we'll share you subsequently the website as well from the government side, which would help you understand at what rate should we sell and where should we sell and who would buy it. Even government itself could buy from you, or else there are different companies which government would connect you that this is the company to whom we have to sell.
Sir, can you share the link through the government initiative? Where we are updating that link because
Yeah, sure. I will
if
share to Arpan sir, and he will communicate with you. So there is a government link where we can check what is the prices for each and every component of lithium-ion batteries, and yeah, that would be helpful for you.
sir, if we want to establish the small level, you just shared 10,000 tons of lithium-ion battery recycling model. Is it so, sir? If we want to create the small level below 10,000 per annum,
Yeah.
is it possible to create establish the units? Sir?
Yeah,
What
sure.
is the
So
feasibility of
this,
profit making for the lithium battery?
yes. Okay, okay. Giving you the perspective about being doing it on a smaller scale, the minimum amount of lithium-ion battery pack recycling can be established, and that can be done at 3 tons per day or 5 tons per day capacity as well. Now, being in that position on working out with that business model is a different challenge, but we have to get the supply chain being sorted out, and also we have to get the overall financial model being placed, and then exercise the overall operation. But yes, there is a possibility we can establish a capacity with starting off with 1,000 or 2,000 square feet facility, and we can restart recycling 3 tons per day or 2 tons per day as well. Yeah.
Okay, thank you. What is the feasibility of profit when we get the return on investment? Feasibility of profit making.
So feasibility of profit is quite a diverse question. It will lead to a lot of branches of sub questions as well. But there are different factors which I can share, which will result you a better profitability. Firstly, it's the amount of connections and network you have, so that we can have consistency of material. Secondly, the ability to sell it in a quicker fashion, because this is all lithium metal salt. You will get the lithium carbonate, and that lithium carbonate and the carbonate which is being extracted in the natural way would be 100% identical with each other. So lithium is a virgin material which would be identical with its original form as well. So so whether you can tap into the existing market and has the ability to sell your products in the existing market, that will also deliver a lot of question. Secondly, the amount of capex you are ready to put in, that would elongate or contract the amount of ROI or the percentage of ROI as well. So given these different parameters, and then there are different other parameters as well, given that these parameters are into place, we can share you the exact amount of ROI and exact amount of uh, break-even period, which is being acquired with respect to your plant or with respect to your thoughts. So that for that reason, we'll have a deep dive on the financial model part and discuss the same.
Sir, other than the government, who is the buyer of the raw materials, lithium and other and other chemicals raw material? Because we don't have
Mhm.
any such market to develop the lithium batteries. We are buying the importing from the China. So after
Yeah.
recycling, other than the government, who is the buyer of the lithium, sir? Lithium and other chemicals?
Yeah. Okay. Uh, so, um, so to answer that, we have different components of a lithium-ion battery pack. Lithium is just 4% of it. Lithium is quite essential, but I can share you that lithium is not the most expensive one. The most expensive one is the graphene. Graphene sales are being executed in the market very conventionally, with their application being done for consumer appliances, as well as with some chip manufacturing companies as well, and sensor manufacturing company. The second most expensive would be cobalt and nickel together. Cobalt would be little bit slightly higher, and lithium would be around like 7,000 US dollars per ton. Lithium find its application in chemical labs, and we have chemical distributors who are selling lithium to other companies. We have pharmaceutical companies as well who are buying lithium. Lithium is actually a material which is very essential for our body as well. So pharmaceutical is the company where we can sell the lithium, but you have to get the quality checks on the purity level as well. Then we have other manufacturers of glass. Glass manufacturing requires lithium. So there is the point where we can sell. And usually it happens that there are 3 to 4 Indian companies as well who is coming up with their own lithium-ion cell manufacturing plant. Godi is one of them, and there are 1 or 2 companies who have recently got their setup executed as well. So there you can sell. Given the scale is not attained till now, they would definitely be taking a help of different company to get to get the slurry manufactured. And slurry is the point where all the lithium, cobalt, and graphene would be present. So slurry manufacturers is what we have to take a look at, and we have to go ahead and tap that market. And yeah, so these are the I think so 4 or 5 areas where we can sell the extracted material, not only lithium but all the rest of the material.
Okay, sir. Thank you.
Thank you. So there is one more question from Shanmugwal sir.
I guess his question I can read from the chat box as well. So
Yeah,
which is
yeah.
safer, pyrometallurgy or hydrometallurgy? And what is the temperature at which lithium is processed in pyrometallurgy? Based on the okay. Oh, that's okay, sir. So based on the uh, yeah, which one is safer? Safety wise, hydrometallurgy is safer. There are different uh, companies or vendors in the market worldwide, not only in India, who would provide you a setup for hydrometallurgical plant as well. And metallurgical plant, although being expensive, it will provide a closed door process to you. So you don't have to intervene inside the internal processes. It will have inward and it will have outward, and you will have single go utilization or processing of a lithium ion cell. With pyrometallurgy, although it's little bit convenient to implement because there are furnaces, there are employees and staff available for operating a furnace as well. So pyrometallurgical is not safe on with respect to furnace is being concerned, but being executed this process on a in a standardized way, we will have discrimination in between both of them with respect to efficiency and with respect to energy utilization and with respect to operating profitability. Where in pyrometallurgy, it's just the leaching with the help of some chemicals and heating of the black mass. That is only thing which is concerned. With hydrometallurgy, we have series of 4 to 5 processes which is being concerned, and each and every process will have different setup or different machinery involved. So if I can share which is safer, I would share which one is preferable in between both of them. Pyrometallurgy is preferable when you have low capex and low ability to set up the overall plant. But if you have higher capex and continuous flow of raw material, hydrometallurgy would be a better option to go. And what is the temperature at which lithium is processed? Temperature would go roughly around 700 to 1000 degrees Celsius for processing the lithium. Yeah.
But
Challenges and chances for
on the
India. Yeah.
previous question, I just wanted to add, like,
Yeah.
is or the pyro recycling still viable compared to hydrometallurgical technique in terms of carbon footprint, the carbon emission?
When it comes to carbon footprint into picture, then definitely pyrometallurgy is not preferable as compared to hydrometallurgy. Because in hydrometallurgy, we get a chemical waste, and that waste can be processed further, doesn't have to be disposed readily, and can be processed, and we can still create a little bit of eco process with respect to
Mhm.
pyrometallurgy. But with pyrometallurgy, it takes a lot of tons of emissions to extract the lithium back. So overall tailpipe emissions or the end of the life emissions for the lithium increases to a very high scale. So firstly, while conceiving the lithium from the base, it will take 15 tons of CO2, and then while extracting or recycling the lithium ion cell, we are again putting in a lot of CO2 into the picture. So
Mhm.
with respect to eco-friendly way, I think so pyrometallurgy is not preferable with respect to hydrometallurgy.
So we are preferring pyro because there is scalability and what you can say the maturity is there.
Yeah.
Hydrometallurgical techniques are still improving or getting developed. But is there any hybrid approach that combines the scalability of the pyro with the efficiency of the hydro?
In both of these process, the common process is the extraction of lithium ion cell.
Mm.
If you are heating, it will be pyrometallurgy. If you are using chemicals, it would be hydrometallurgy.
Mhm.
Combining both of this process is, I think so. I have not heard any theory or research paper on the same, because both of these set of machinery is completely different, and the number
Mm.
of steps are also different. So I would prefer going to a single approach. If it is hydro, then go ahead with hydrometallurgy. Or if you want to go with a low capex model, then pyrometallurgy is a definite answer. Yeah,
Understood. Yeah. Thank you.
thank you. So Mr. Prashant sir has a question. What is the biggest challenges and chances for India to become a leader in battery recycling? I cannot answer that on a very larger perspective, but battery recycling is something which India has to do eventually. India has a plan that critical materials is becoming a block bottleneck in the overall development of a nation as well. If we want to go all electric, if we want to go all eco-friendly, we have to get lithium-ion batteries and some rare earth material in-house, and then start processing it as well. Critical materials, as I have mentioned, they are becoming a bottleneck as well. So challenges and chances, it's better to have all the materials coming in, has to be recycled and then utilized internally or being exported as well. So I can share chances of India becoming by becoming a leader. That would require a further double tap on uh, yeah, that would require further double tap on the technology and the amount of lithium reserves we should have. To give you a perspective, copper is like India is leading producer of copper, one of the leading producers. Even China buys about 5,000 tons or $500 billion of copper from us. They and China's leading supplier for copper is Japan. They would be selling around $2,500 billion of copper to them. So 80% of the copper we utilize or we use in India is being recycled, and we are recycling it and we are exporting to China as well. So because we have plant in-house, we have mines which is producing copper, and then we are efficient in recycling the copper as well. So that's the reason we have become a global leader for the same. Similarly, I can share about aluminum. Aluminum, again, India is a leader in producing aluminum. 75% or 70% of the aluminum we utilize is a recycled aluminum. It's not the original formed aluminum. And that's the reason getting a recycling is better. It will suffice to our internal requirement. Also, we are a leading producer and exporter of aluminum as well. So that would also that has also brought a lot of value to India. So I think so. It's a broader question where a single part cannot be answered with a single line. But recycling is very essential and it has to be incorporated in India.
Thanks, Ravindra sir, for joining us today and share your insights on various waste management technologies and the policies regarding to lithium-ion recycling. So, thanks everyone for joining us today in Gyaniki Tech Talk session. Hope you all get the a brief idea about this technology, waste management, how we can go ahead in the future, and what are the limitations are there. And we are planning to coming with some eye-opener session related to this subject. So in coming week, we will launch that course with association with Motorall. So we will publish this course in Gyaniki. Uh, and this course will be like 3 days workshop or uh, of a program, online program that will be give you a brief idea about the technologies, what are the policies are there, how to connect with the industry, who are the suppliers, raw material from this particular segment companies. So like eye opener session type of course will be there. So thanks everyone for joining us today. Yeah, stay tuned with Ganiki. This video will be you can check in our YouTube channel also. Thanks everyone for joining today. Thanks Ravindra once again for making this session successful. Yeah.
Thank you, Arpan. Thank you for hosting. Thank you, Gyanagi team for coordinating and getting this session online. We are looking forward for the Gyanaki's post for a deep dive session as well. And so thank you. Thank you for attending as well. Thank you.
Thank you.